Hello, good morning, everybody. Welcome to this DDoS attack mitigation session. My name is Aviv Abramovich. I'm with Checkpoint Product Management, responsible for DDoS and our DDoS products. In this session, we are going to share with you some really new, exciting news and new products and new partnerships we have to offer DDoS attack mitigation to our customers. This session is being recorded, and you can ask questions during this session. Just click on the Q&A button at the bottom of your screen and just type in the question. And without further ado, I would like to introduce Ezer Goshen, VP of Business Development. Ezer, the floor is yours.
Hello, nice to meet you, everyone. My name is Ezer Goshen. I'm responsible for the partnership between Radware and Checkpoint from Radware side. I'm a VP Business Development at Radware. We are excited to come for this session together with you, organized by Checkpoint. We have signed an update agreement with the Checkpoint last December, and with this new agreement, it's expand the portfolio of solutions powered by Radware from the legacy DDoS protectors to the new DDoS protectors version 8 with all of these capabilities. This include also a WAF solution, Web Application Firewall, and also SSL inspection solutions. Those solutions are on-premise and also on the cloud. And also we have integrated those solutions into Checkpoint Infinity architecture. I would like to present Amir Daan. He will introduce himself and will start to present the agenda. We will present the threat landscape, DDoS attack mitigation offering in the cloud and on-premises, and we will summarize a few interesting things for you to know. Amir, the speaker is yours.
Thank you, Goshen. Hello, everybody. I'm very excited to participate in this session. My name is Amir Daan. I'm a product manager at Radware, leading the portfolio of DDoS protector appliances. And in this session, I'd like to cover a bit what are the recent trends in the threat landscape, and then present to you our latest lineup and talk about some of the exciting new features we've recently launched for the DDoS solution. So let's start by reviewing a couple of slides from recent research we have done with some of our customers. And this slide is about trying to assess what is the primary goal for cyber attacks. And the nice thing from our perspective is the primary goal is related to service disruption. And DDoS is all about service disruption, right? Because if you actually disrupt the service, DDoS is actually service disruption. And if you look at the implications of that, we see that there are a lot of negative results for such service disruption, right? You are losing productivity, you have customer churn, the experience is bad, and you lose reputation, right? So service disruption is number one, even more than data theft, which is, I would say, one of the major reasons for cyber attacks. If you get a bit deeper into the DDoS attack landscape, we see on the right side and a shift from what we call volumetric layer 3, layer 4 DDoS attacks to application DDoS attacks. So for the application DDoS attacks, there are both volumetric DDoS, application DDoS floods, as well as kind of low and slow DDoS attacks. But there is a trend towards applications. And for the specific vectors, we see an increase in encrypted floods like HTTPS. We see an increase in DNS attacks. We all remember the infamous Mirai, end of 2016. We see an increase in new attack vector, which is what we call burst attacks, and we'll discuss it a bit later. So overall, there is an increase in both application layer attacks and the complexity of attacks as well. Now I want to discuss a bit multi-vector DDoS attack campaigns. So essentially, if you look at a common data center architecture, starting from the left, there is the internet pipe or the router, then the firewall, IPS, IDS, ADC or load balancers, and there are the applications, the servers and the databases. DDoS attacks actually spans all these components, starting from saturating the internet pipe through floods, which is based on large volume network floods, then affecting stateful devices such as firewalls with attacks that actually exhaust their resources, and then moving into the applications with attacks that are both volumetric but at the application layers like HTTPS, DNS, encrypted SSL, encrypted HTTPS attacks, as well as attacks that are kind of low and slow, or attacks trying to crack the servers, or even app misuse. So essentially, a Radware solution incorporates the needed ingredients to actually cover all these attack types. So now you see the various technologies we use in our portfolio to provide a complete attack coverage for enterprise data centers. Some of them are part of our on-prem DDoS appliance protection technologies. Others are part of our cloud DDoS offering, okay? And also our web application firewall, which is also part of the offering for you guys, covers some of the more advanced application layer attacks and low and slow attacks. Now focusing on the DDoS appliance lineup, we recently released new portfolio for the DDoS appliances, which is based on state-of-the-art hardware technology, as well as re-architectured software design that uses parallel processing to achieve very high capacities and enjoy the latest functionality we get from modern chipset hardware technologies. So the first one is the DDoS Protector 6, then the 2060, and the largest one, which is the 200-400. And if you look their target markets, we see that the 6 addresses small enterprises, the 20 and 60 medium and large enterprises, and then the 200 and 400, I would say, primarily carriers, cloud providers, and very large enterprises. So we actually span all of these market segments with attack mitigation throughput that starts with 6 gigabits per second on the DDoS Protector 6, up to 400 gigabits per second on a single device with a DDoS Protector 400. Also, please note that the new DDoS Protector 6, 20, and 60 includes an embedded SSL hardware acceleration engine that allows you to provide encrypted flood protection with an integrated device without a need for an external SSL offloading device for that task. So everything is incorporated on a single device. Here there is a snapshot of the data sheet where you see some more of the capabilities. I think that the nice thing to see besides the numbers is the fact that for the SSL TNS connections per second, our SSL hardware engines supports market-leading figures for the rate of mitigation we can achieve on HTTPS floods. And this is, again, a new addition to this product lineup. Actually, we've covered the appliances in short. Now I want to talk a bit about the most interesting part, which is the technology or the features that we provide as part of this on-prem lineup of appliances, and talk about the unique or the key selling points for the DDoS protectors in mitigating DDoS attacks. So I think that the most important thing for you to take out of this session is the fact that our detection and mitigation technology is unique in the sense that we employ what we call behavioral or machine learning algorithms for attack detection and mitigation, which is quite unique, I think, in the market. So if you look at the normal or a common flow of attack detection and mitigation within our solutions, there is the first phase, which is the detection of an attack. And we'll talk about it because it's important to detect or distinguish real DDoS attacks from flash crowd. Then once an attack is detected, you want to characterize it in order to be able to mitigate the attack with minimal false positives. And then once you characterize the attack, you can actually mitigate it. There are various techniques of doing so. And also you want to make sure when to terminate the attack mitigation once the attack ends. Let's take a look at some of these steps and see what is unique with Radware or the DDoS protector technology. So essentially, when you detect an attack, because we are talking about the DDoS world, which is primarily volumetric, right? It's easy to detect attacks based on rate. So if there is a flood, essentially the rate, you get a surge of traffic throughput, and then you cross a certain threshold. And if you set the threshold and you cross it, there is a DDoS attack. The problem with that approach, which is commonly used by the competition, is the fact that you cannot distinguish between a flash crowd and real DDoS attack. Because if the surge is legitimate and you only base your detection on rate, you will actually detect attacks when there are actually legitimate surges. Our DDoS protector employs behavior-based detection or machine learning algorithms to be able to detect traffic anomalies with the ability to distinguish real attacks from flash crowds. And if we look a bit deeper into how this is being done, we see in green what a legitimate flash crowd looks like. So there are two figures on the legitimate flash crowd section. There is the rate analysis, and then there is the TCP flag distribution analysis. Our competition uses rate analysis. So as I mentioned, it's okay, but again, if this is a flash crowd, you cross a threshold, you detect an attack, although it might not be an attack. Why is that? Because if there is a legitimate surge of traffic and the characteristic of the traffic is still normal as you can see on the right end, the TCP flag distribution analysis shows that the percentage of ACK packets is still around 50%, and the data packets are still around 30 or 40%, etc., the characteristics of the traffic are still the same. You understand that although there is a surge of traffic, this is not an attack. This is legitimate these are legitimate users accessing your services, but this is not an attack. On the other end, in contrast, if we take a look at the reset flood attack, then there is the rate analysis is the same, right? There is a surge, you suspect it is an attack. But if you look at the TCP flag distribution analysis, you will see an anomaly on the reset portion of the traffic. And then you understand that indeed the combination of rate surge and anomaly on the distribution analysis, together you actually conclude that this is indeed an attack and not a flash crowd. And the example here of TCP flag distribution is only one of the controllers, we call them controllers or features or attack vectors that we are able to detect based on this behavioral analysis, but there are a lot of additional attack vectors for which we do exactly this type of analysis, and the sole purpose of it is to distinguish flash crowd from real DDoS attack. So this is one point related to detection. The second point is how you actually characterize the attacking or offending traffic, right? You detected an attack, you are certain it's not a flash crowd. Now you want to mitigate the attack or the offending traffic. And you want to make sure that the mitigation is that surgical that you only mitigate the offending traffic and you don't create false positives. So the common practice in the industry, again, on the left side end, is to either use a rate limit, which means everything beyond a certain threshold is being dropped, which is both legitimate and attacking traffic, and it's not good. Or you're trying to surgically create a signature to block or mitigate only the offending traffic, but this is a lengthy process, right? It can take not hours, even days in complex attack campaigns. Our DDoS protector can create a signature automatically with up to 18 seconds. And we have a very nice algorithm to do that with a closed loop feedback. We start after 10 seconds, we start with the first simple signature, and then with the additional 8 seconds, we optimize the signature to reduce the false positives by adding more and more parameters to it in order to surgically mitigate only the offending traffic. And this is a full hands-off experience without any human intervention. It's being done automatically. And this is one of our key selling points as well. So I talked briefly about our behavioral technologies or machine learning-based detection mitigation, which is applicable to volumetric attacks as well as application attacks like DNS that we'll discuss briefly later. But now I want to briefly show you what are the various protection models we have in our portfolio or in DDoS protector. So essentially there are like 3 tiers, right? We are protecting the application, we are protecting the server, we are protecting the network. And the bullets you see under each one are essentially protection engines or features that allow us to provide full protection for the data center for DDoS attacks. So if I try to classify them based on what is the mitigation technology, we believe in behavioral or machine learning protections. And this kind of protections span the application, server, and network. We try to implement sophisticated mitigation capabilities in all tiers. We also have mechanisms to do sophisticated or advanced mitigation. So, for example, if we suspect an end user to be a bot, and we want to make sure we actually drop traffic only from bot sources, we can challenge them. And there are various challenges, mechanisms, depending on the exact protocols or attack vectors. It can be in the scene, in the layer 4, it can be at the application layer, in DNS, in HTTPS. Each one has its own specifics. But essentially, the nice thing about it is that you are not simply dropping traffic. You drop traffic only for those users that you know are bots and are not legitimate end users. And this is something, by the way, ACLs in routers cannot do. So there will be a claim in some cases that I'm using ACLs in my Cisco or Juniper routers, and they have a lot of flexibility in that. But for example, they cannot distinguish bots from real users, right? They cannot do challenging. So this is one thing that DDoS protector can do and routers not. Additional layer of protection is about access control. It's not that sophisticated, but in some cases, users know exactly what are the allowed sessions, and they can use whitelisting in our DDoS protector. They can limit the number of layer 4 connections per second, etc., etc. So we also have this kind of capabilities. And on top of that, we have what we call signature protection that is also accompanied by a threat intelligence feed. This is a mini, I would say, IPS. But this IPS, the uniqueness of it is that it is centered around DDoS. So here we actually have a research team that creates on a weekly basis a bunch of new signatures that are focused on DDoS vulnerabilities and attacks. And this is also a service that is part of our DDoS protector. Okay, now I want to briefly discuss 3 more attack vectors, which are quite interesting, and show you what we are doing with that and why we are so unique. So the encrypted flat protection is a new feature we just released, I think 1 month ago. And the nice thing about it that it is very unique in the fact that we don't need a private key. We don't use certificates. But first, let's define the attack. Here I'm talking about an attack vector that is being used by attackers after they established a TLS session with the HTTPS service application. And once the session is established and it's a legitimate session, they flood the server with HTTPS requests in a rate that the servers cannot sustain. So this rate actually yields into DDoS of these services. What we are doing here, we are actually using our behavioral algorithms to detect the attacks, again, distinguishing between flash crowd, it's a very important point, to end real attack campaigns by using rate-based and also traffic characterization, and their combination allow us to distinguish real attacks from flash crowd. And we do that, the nice thing is that we do that with no traffic description, okay? So we had a lot of research in our CTO and R&D how to do that. We invented some nice algorithms, and this is a key capability that I believe we are the first and only player in the market to do so. We still are stateless. Essentially, the DDoS protector is a stateless device. I wouldn't say that it doesn't have what we call a session table, but the session table is not a prerequisite for the DDoS protector to be able to serve legitimate users or block attacks. It is only being used for attack detection and mitigation, but it's not like a firewall or a NAT router. It's not mandatory to have a refresh updated session table to serve the end users. And another point, it's ingress only. So in many cases, customers want the DDoS protection, like IPS, to sit only on the ingress path, while returning traffic might not even being processed by it. So this is also another capability that we are providing. Once we detect an attack, again, keyless, no decryption at all, we try to characterize the attackers, right? Similar to what I explained beforehand. And here again, we have a lot of technology and intelligence in our DDoS protector to be able to distinguish suspected attackers from legitimate users. Once those attackers are revealed, we start to mitigate their attack by dropping their packets. There is also an optional capability here that if you do want to have a higher level of sophistication on the attack mitigation, and you have the private key and you are ready to install a certificate, we can do challenging. We can authenticate the end users up to the HTTP layer, including advanced JavaScripting challenge response, which again allow us to make sure that the attacker is a legitimate user and not a bot. And then obviously all that allows us to still serve the legitimate users. So this is one nice thing. The key point you need to remember here, that we are the only vendor today that allows you to offer encrypted flat protection without key, without certificate. The second attack vector I'd like to refer to is DNS, right? So a lot of large enterprises, cloud providers, obviously carriers, are using DNS infrastructure for internet services. So DNS is one of the protocols that is suffering from many attack vectors. I will not cover each and every one of them, but we'll focus on a very sophisticated one introduced by the Mirai open source botnet code, which is called the DNS water torture. The nice thing about it, and we'll see this attack vector, how it looks like, is that in order to mitigate it, you don't have any other choice but using, besides using a positive protection model. We do that while still providing the deployment flexibility being ingress only, which is not trivial because there are some additional players in the market that offer DDoS DNS protection services, such as DNS application developers that use full DNS stack to mitigate these attacks, but they are stateful and they need to look at the traffic, both the ingress and the egress. We don't need to do that. And obviously we do that with the protection accuracy that is needed from the DDoS protector based on, again, behavioral mechanisms. We are stateless, and we create a granular real-time signature to block this kind of attacks. Let's take a look how this attack looks like and what the competition does to mitigate it. So the attack on the left side, and you see what is the attack pattern. So for example, this kind of attack, the random subdomain flood attack or the Mirai water torture attack, sends a flood of DNS queries on a target DNS infrastructure. Now, the flood looks like that. On the green queries, you see legitimate users. trying to resolve domain names to IP addresses. The attacker injects a flood of queries with fully randomized domain subname. These subdomain names are not available on the DNS infrastructure. So what happens in this case is that the DNS server and the recursive DNS server, all the DNS infrastructure on the way, will try to resolve the query. They will not find any match, and they will get back with an error message, right? This recursive process can actually bring down a DNS infrastructure. This was actually what happened late 2016 when the major part of the internet went down, including major sites like CNN.com, Twitter, etc. Our competition is based on rate limiting. So they measure the query per second, QPS, and once it crosses a certain threshold, they start to rate limit the traffic. By rate limiting, they drop both attacking as well as legitimate traffic, which is not good, false positives. We try to solve that. And the way we work is by learning in peacetime the legitimate domain names. We learn them. We have a huge table. We are using sophisticated storage structures that are very thin in memory capacity, and we can learn a huge number of domain name records. And once we detect an attack, we actually go into positive protection model. We block everything to the attacked domain, in this case PayPal.com, aside to the legitimate DNS records or domain names. This way, we actually eliminating this attack vector, which is quite sophisticated. And the last vector, or additional two actually, the first one is the burst attack protection, which is very nice. Before talking about what we do here, I just mentioned briefly that a burst attack campaign comprises of multiple attack hits. Each one is very short, can be few seconds only, with peaks that can reach hundreds of gigs. And we saw such attack campaigns in our cloud DDoS services. Okay, some of the customers actually suffered from such attack campaigns. The tricky point here is that with this attack campaign, if the attack hit is only 5 seconds long, our behavioral DOS technology cannot mitigate it because we need approximately 18 seconds. This is what I mentioned earlier when I explained about it, right? So 5 seconds, then it stops. Additional 10 seconds, it stops, etc., etc. It totally bypasses our mitigation technology, and it does the same to the competition that is using rate-based detection, right? Because in rate-based detection, yes, they will rate limit it, but with a lot of false positives, and the only way to avoid false positives is to create manual signature. They cannot do that with an attack pattern like that ceases after a few seconds each, right? So what we have done here is actually extended our behavioral DOS mitigation engine, and we are now able to create a signature by following the sequence of attack hits. So if the first one lasts 5 seconds, we start to create a signature. It stops. We don't lose our cache, our state related to the signature that we try to create. Then the second one comes, additional 5 seconds. We continue from the point where we stopped. And we need aggregated 18 seconds in total over multiple attack bursts. It doesn't matter how many, but once we reach 18 seconds, we have a signature in end, and this signature will be applied to the next burst automatically. So in this way, we are actually mitigating this kind of stealth I would say, attack vector. And the last one is another type of encrypted flood. This one, in contrast to the previous one that I described, here the attack vector is as follows. The attackers try to create a flood of new TLS session establishment. So they are actually launching a lot of TLS sessions on a given time interval, trying to overwhelm the HTTPS servers with a lot of encrypted computing needed to open the TLS session until the server is dead. What we are doing here, first of all, in peacetime, which is the green arrow you see, in peacetime we are not doing anything, right? There is no attack. Once we detect an attack, we start to employ our embedded SSL hardware accelerator, and we decrypt the request. We challenge it based on advanced layer 7 challenging, and if the client is legitimate, he will pass the challenge, right? He will get back to us. Once we see the response from, it means that the client is authenticated, and we redirect it again to the protected server, and now we are not sitting in between. We are not a proxy. We are out of path, and the client talks directly with the server without delay, without us being in the middle. The nice thing about this is that we actually, I would say, we do that with minimal latency, right? Because in peacetime, first of all, nothing is affected. We are not in the middle. We are not in the path. We are not doing anything. Even once there is an attack, we are only challenging or authenticating the first session request. Once the session is authenticated, we are still getting out again, and the client talks directly with the server. So the minimal latency is both in peacetime and during wartime. By being able to stay out of path in the majority of the time, we actually also serve the end users because we maintain data confidentiality. We are not decrypting, encrypting all the time, okay? And we do that based on, again, a stateless solution that is ingress only and provides nice deployment flexibility with a scalable architecture that can scale up to 100K connection per second, which are TLS connection per second. That's all on my side. Thank you.
All right, thank you, Amir. Hello, everyone. My name is Eyal Arazi. I'm a product marketing manager here at Radware for Cloud Security Services. And what I'd like to do over the next 10 minutes or so is to discuss with you the DDoS Protector cloud service and how it can augment our premise-based devices to provide a comprehensive protection against DDoS attack. So the Cloud DDoS Protector is a cloud-based SaaS DDoS mitigation service based on the Radware technology that Amir walked us through in the previous segment, and based on a network which is owned and operated directly by Radware. Now, from the customer's perspective, there are a number of key advantages in deploying a cloud DDoS mitigation service. First and foremost is the issue of volumetric protection. In this day and age, the size and scale of denial of service attacks is constantly increasing. The largest attack to date, I think from 2018, was measured at approximately 1.7 or 1.8 terabits per second. This is a size of attack that will overwhelm not just any given enterprise, but in some cases, entire carriers or even whole countries. Protecting against this type of large-scale attacks, which are becoming increasingly frequent, requires not just premise-based protections, as Amir walks through, but also cloud-based protections with the capacity to absorb these attacks and mitigate them. So the volumetric protection is, first and foremost, the key advantage here. Another advantage, however, is the issue of flexibility in management and deployment. The Cloud DDoS Protector service is a fully managed security service based on Radware's team, and therefore it takes the burden off the customer in terms of management and the need for security expertise. Many organizations lack either the staff or the expertise to manage on their own and end up either having to hire additional staff at expensive rates or leave those configurations unattended or not as well attended as they can be. And a fully managed security service takes that burden off of their shoulders and effectively outsources it to Radware, which is an expert specifically in protecting against such DDoS attacks and similar types of attacks. So this, in addition, there's a lot of operational flexibility as well. A cloud service can be started or stopped at any given time. It can be expanded to cover additional assets, and payment is on an as-you-go, a pay-as-you-go model, and it doesn't require as much planning ahead and allocation of capital as purchasing equipment. Finally, we have the issue of protection of applications not located inside of a physical data center. This is particularly important for applications and services hosted on public cloud providers such as Amazon AWS or Microsoft Azure. And in these cases, there usually is no data center or physical premise which you can place a device, and therefore what you would need to do in that case is to rely on a cloud-based service. So again, from the customer's perspective, a number of key advantages for utilizing a cloud service, either to augment or to replace a premise-based physical appliance. Now, looking specifically at Radware's and Check Point's Cloud DDoS Protector service, it comes in a number of deployment flavors. So it can be deployed either as a pure cloud service, either on demand or always on, and we'll discuss each in a moment, or it can be deployed in a hybrid configuration which combines both cloud-based protections together with a physical appliance to enjoy, so to speak, the best of both worlds. So let's look at each of these in a bit more detail. So starting with the pure cloud deployment models, first of all, we have the on-demand option, which is what you see in the middle of the slide across from you. The on-demand service, as the name implies, kicks in only once an attack is detected and activated. So on a routine basis, during peacetime, so to speak, traffic will flow directly to the customer location without any interruption. The advantage for that, of course, is that there is no additional latency introduced. Only if and when a DDoS attack is detected using volumetric net flow detection will a diversion be initiated using either a BGP or DNS diversions, depending on the type of asset being protected. And once a diversion is initiated, traffic will be routed first to the cloud-based scrubbing center, which will inspect all the traffic and scrub out any malicious traffic, and then it will forward only clean traffic on to the customer location. Now, this diversion will persist for as long as the attack is going on, and once the attack is identified as having been stopped, it will revert back to the original situation and traffic will resume flowing directly to the customer. The advantage for the customer in this type of deployment, as we said, is no latency during peacetime, it's simplicity of deployment, low management overhead, and cost, which is usually lower than the other deployment types that we have. So that's for the on-demand pure cloud deployment option. The second pure cloud deployment option is the always-on. The always-on, as the name implies, means constant uninterrupted protection. Under this deployment option, all traffic is routed at all times, is diverted to the cloud-based scrubbing center, which then inspects traffic against any malicious activity and forwards only clean, legitimate traffic to the customer location. The advantages here are a real-time detection and mitigation. All traffic is inspected at all times. However, the cost here is that there is usually some minor added latency just as a result of diverting the traffic through a third-party location. Now, the amount of latency will vary depending on the exact location and distance from the scrubbing center. In most cases, it is not a high amount in any case. However, for organizations or services that are particularly sensitive to latency, this might be an issue that they would want to consider. So that's for the always-on pure cloud deployment. Now, a third type of deployment that we offer is the hybrid deployment, which combines both cloud-based protections together with a premise-based hardware appliance. Under this model, traffic on a routine basis will flow directly to the customer location, where it will be analyzed and inspected by the on-prem DDoS protector. The DDoS protector will take care both of clean traffic as well as small-scale attacks, which it can handle. However, if and when it detects a large-scale volumetric attack that can either overwhelm the device itself or even saturate the pipe feeding into the network, then it will automatically initiate a diversion, which will then divert all the traffic first to the scrubbing center, which will clean out all the malicious activity, and then forward it back to the customer location. Now, using the hybrid approach gives you the best of both worlds. It gives you both the constant uninterrupted protection of the always-on model that we discussed earlier, but without the latency. And it also gives you the scale and breadth of protection of a cloud-based scrubbing center and the capacity that comes with it as a pure cloud service. So one more issue to emphasize when it comes to our hybrid protection is the signaling that goes on between the premise-based appliance and the cloud. Radware has developed an advanced signaling technology called defense messaging, which is integrated into a DDoS protector, which allows for not only signaling when there is an attack, but actually for sharing security policies, sharing traffic baselines, sharing attack signatures, and so on between the premise-based appliance and the cloud scrubbing center in order for seamless integration and transfer of data if and when a diversion is required. This allows for shorter exposure windows when there is a diversion so that the cloud scrubbing center doesn't need to learn everything from the beginning, but rather can take all the information passed by the appliance and utilize it from the first moment. So let's look at the hybrid deployment in a bit more detail. So as we mentioned, under a hybrid deployment option, you have both a premise-based DDoS protector as well as the cloud-based cloud DDoS protection service. So during peacetime or during day-to-day, all the traffic will flow directly to the customer location where it will be inspected by the on-prem DDoS protector, which will take care of small-scale attacks, application layer attacks, and so on. However, if and when a large-scale volumetric DDoS attack is detected, then in that case, automatic diversion will kick in, which will then divert all the traffic first to the scrubbing center, which will then clean out all the malicious activity and forward only clean traffic back to the customer location. Before we wrap up this segment on cloud protection, there are a number of points that I'd like to emphasize about the considerations and criteria for buying a cloud service. Now, it's important to keep in mind that when you buy a cloud service, and specifically Cloud DDoS Protection Service, it's more than just the technology. Rather, it is a combination of both the technology, the network, and the service itself. And with the cooperation between Radware and Check Point, we are able to provide customers with all three. So the technology component of this is based on Radware's Defense Pro technology, which Amir walked us through during the previous segment. He explained in detail about all the different technological capabilities, but all of what he talked about, whether it's the behavioral-based detection, the both rate variant and rate invariant analysis engine, the automatic signature creation engine, the SSL protections, and so on, all of these are also available in the cloud offering as well. The cloud offering is built from the ground up using the Radware technology stack, utilizing the exact same technology at every level. However, the cloud also gives you the advantage and scale of a globally distributed network. So the Radware's cloud scrubbing network is a dedicated scrubbing network with its own independent capacity, dedicated to mitigation of denial of service attacks. Currently, there are 11 scrubbing centers worldwide, distributed in major cities as well as major truck communication hubs. And it has 5 terabits of dedicated mitigation capacity, which is expected to grow to up to 10 terabits by the end of 2019. Now, if you recall, currently the largest attack observed to date was just under 2 terabits per second. We are currently at 5 and expected to grow to 10. So this keeps us at least 2 to 3 to 5 times ahead of the largest attack ever detected, and we like to keep it that way just to make sure that we can serve our customers as well as absorb even the largest attacks. Finally, the last piece, of course, is the service segment. As I mentioned earlier, the Cloud DDoS Protector service is a fully managed security service. It is run by Radware's Emergency Response Team, or ERT, which is one of the industry's largest and most experienced security teams, dedicated specifically to protection and mitigation of web-based attacks for WAF and for DDoS. So again, by using this service, organizations gain the advantage of Radware's expertise, as well as taking the burden off of their own shoulders and not needing to invest time and staff in becoming experts in their security. So just to wrap up this segment, when you're talking about a cloud service, either as a replacement or to augment a premise-based device, you enjoy the benefits of volumetric protection. You have the multi-layered protection that comes with the hybrid deployment option. You have flexibility in service of a pay-as-you-go model and a subscription service. And in addition, you have granularity in deployment, where organizations, especially large organizations, might want to deploy different types of protections for different types of assets. And by using Radware and Check Point, they can mix and match different types of protections and different types of service for different types of assets that they have in order to achieve the best and optimal solution for them. So just as a summary of what we discussed during this presentation, some of the unique protections that Radware's technology stack offers against DDoS protections is IoT botnet protection against large-scale IoT networks, which launch DDoS attacks, protection against dynamic IP attacks using our IP-agnostic behavioral analysis engine, zero-day protection, protection against SSL DDoS floods, burst attack protections against hit-and-run DDoS attacks, as well as protections against of attacks against DNS infrastructure, which Amir outlined earlier. So now let me pass it back to Ezra Goshen for a discussion of Select.
Happy to be back with you. So we have focused in this presentation on the DDoS solution, on-premise and cloud solutions for Checkpoint solution powered by Radware. As you know, there are additional solutions by Checkpoint for powered by Radware on the WAF, on-premise and cloud, and also SSL inspection. You can find all the material branded for Checkpoint, branded brochures, presentations, and a lot of other stuff on your wiki pages. If you find something missing, just let us know, Checkpoint marketing and product management, and we will complete it. In addition, I can tell you that it's very important that now all part numbers, all Checkpoint SKUs are available for you in the user center portal of Checkpoint. You can select over the product catalog the DDoS protectors, and you can see all type of solutions from there, and addition services relevant for this. You can also just select to download the catalog or search according to initials of, for example, AL for the Alteon solutions or DP for DDoS protectors, and get all the information. There are some missing part numbers which will be completed this week, which will give you all portfolio of wide solution of Checkpoint powered by Radware. So another issue I would like to say is that actually this is an OEM partnership, and we provide end-to-end solution and complementary solution for Checkpoint, and this enables you to sell new products and grow your pipelines, provide end-to-end solution, win new logos, and very important also to protect your installed base and blocking the competition. So feel free to approach us for any needs you have. I think it's very important for you also to interact with Radware local people to help you identify the requirements and set up with you the best solutions. And we will lead you and help you all the way from start until winning together. I think working together is very important for increasing the winning rate together with us. We see it's coming last opportunities. I would like also to mention that we are in the North America now. We are sponsoring about 10 local CPX events. We are presenting not as a Radware, but Checkpoint solution powered by Radware. So the table is branded for us. We joined the Miami, Houston, Minnesota, Vancouver, in Brazil, Dallas, and some more. And so this is the time to do much more together. So good luck, and anything you need from Checkpoint side, you can interact with the Aviv and the Noah from the headquarters, and in Radware with Israel from the marketing, and with me, Goshen. Thank you very much.
Thank you, Goshen, and thanks everybody that's still on the call. I'd like to remind you that we might still have a couple of minutes for some Q&A, so if you have any questions, please go and type it in the Q&A box. Goshen and the team over at Radware, if you don't mind, there are, I think, a few questions already posted there. If you can address those, that would be wonderful.
Okay, so I see a couple of questions, if I may. Since there are 3 pillars, application, server, and network, Checkpoint provides some kind of basic DDoS protection against application, server, network. How Radware does complement to our IPS solutions, stateful versus stateless? Where do we not comply?
So, if I understand the question correctly, the question is about how do we complement your IPS solution where you do not comply. So I think that our IPS complements yours by the fact that we are solely focusing on DDoS IPS. We are releasing a bunch of signature updates through our feed on a weekly basis. The signature involves various capabilities related to things that are DDoS centric. So for example, if there is a new bot emerging and we want to be able to block the control interface between the bot manager and the compromised bot endpoints, we will create a signature that will prevent a bot manager to compromise your or the enterprise internal end users or PCs or hosts, and this is something that is part of our offering centric around DDoS. So again, our IPS, I would say, is primarily around DDoS mitigation. This is the major difference.
Okay. Second question is, does Checkpoint Radware appliance do offloading SSL, or we need to purchase another Radware appliance? Where is it? Or who does the man-in-the-middle SSL inspection, Checkpoint or Radware appliances? So yes, we have the category of Alterons which implement the SSL inspection. It includes SSL inspection, outbound and also inbound offloading. So this provides a separate appliance solution for these purposes. When we are providing the SSL inspection, we are the man in the middle here, and we provide service chaining, service scalability, and other functionalities. This will be covered on separate webcast on the WAF solution, on-premise and on cloud. We have also very unique capabilities in these. We are doing negative protection, also positive protection, which is unique in the market.
I'd like to add to that the integrated SSL capabilities within the DDoS protector are actually used to mitigate certain specific common encrypted attacks. The SSL offloading allows you to decrypt the traffic in order for your solutions, your Checkpoint technology, native technology, to be able to look into the payload and do some nice thing with it. So this is where the SSL offloading comes into play.
Yeah, and not spend all the performance of the security gateway on decryption encryption. Okay, the first question is on the application layer. How does Radware compares to other vendors, Fortinet, Cloudflare, and Akamai regarding WAF?
So let me divide this answer in two. First of all, there are the DDoS application layer protections, and there's WAF, which is its own separate category. So in terms of DDoS protections against application layer attacks, so Radware provides protections against these types of attacks in the exact same way it provides against volumetric layer attacks, against layer 3 or 4 attacks, using our behavioral analysis engine and automatic signature creation capabilities. This is in contrast with our competitors in the cloud space, for example, Akamai, Imperva, Cloudflare, and so on, who utilize only rate limiting against application layer protection. Apart from that, one could deploy a WAF in order to or deeper level of inspection of application layer traffic, as well as protection against application attacks such as SQL injection, cross-site scripting, and so on, which is what web application firewalls are commonly used for. We did not discuss Radware's WAF offering in this presentation. However, we do provide a WAF offering as well, which, like our DDoS offering, is based on a positive security model, which creates security policies tailored to the customer's legitimate traffic. And this is, again, in contrast with most of our competitors, including Akamai and Capsula, Cloudflare, and so on, who use only negative security model WAF protections based on predefined manual rules. However, that's a separate discussion, and I encourage you to reach out to the contacts that Goshen mentioned if you want to learn more about these products.
Okay. Another question is cloud DDoS protection VS appliance. Do Radware offer DDoS in virtualized version instead of an appliance? Do you recommend your customers going that route? If so, how does this queue works since I was not able to see in our website? So we provide both appliances and also virtual appliances. Currently, it's not in Checkpoint price list, but of course, this could be if there will be a requirement from the field for that. We have here also Aviva, our product manager, which will be, if necessary, we'll be happy to add this. It's of course depend on the utilization. If you need to use virtual appliance, then of course you can use it and have the same functionality. You want to add something?
Yeah. So the question of virtual appliance versus a SaaS service really hinges on the issue of management. A virtual appliance is like a physical appliance, something that is managed directly by the customer itself, with the pros and cons that are associated with it. If the customer wants, full control, then they might opt for it. However, it requires a higher overhead and management on their end. In addition, ultimately, the capacity that is available on the virtual appliance is whatever it is that they purchase in the license and the capacity of the pipe leading into their network. In contrast, when you opt for a SaaS service, the Cloud DDoS Protector option, you have management which is done and configuration which is done completely by Radware, therefore taking the management overhead from the customer. And you have the bandwidth and the capacity of Radware's scrubbing network, as we mentioned, 5 terabits of mitigation capacity, going on 10, which can be used to absorb and mitigate even the largest attacks, which is usually far more capacity than most customers have.
Okay.
That's the one.
I saw a question regarding the DP65. I don't see it here anymore. But anyway, some more licenses like DP65, DP602, and DP22 are on the way. They are going to be by the end of this week in your product catalog as well. The people of which handlers queues in Checkpoint system are working on that. That's supposed to be by the end of this week. Last question here is, could you address the best way to connect with our sales counterparts in the field and deal registration process? So yes, it's very important to interact between people of Radware and Checkpoint. I think it should start also before the deal registration process to kind of synchronize accounts or to help you identify also opportunities to make the sales enablement to you. And then, of course, you can go to the field and find the opportunities. When you find opportunities, of course, you need to make a deal registration. So the deal registration process is something well-defined process at Checkpoint. So what it includes is that Checkpoint rep creates a Salesforce ID for the every new DDoS deal. Then automatic notification of the new deal registration creation sent to Checkpoint desk. Then desk registered the deal with Radware. They send us actually deal registration request, and then it creates automatically a lead in our system, in our CRM system, which we have to accept or reject within 72 working hours. And also we ask our people to interact with you whenever they get the registration to find out about the opportunity, to coordinate with you, to provide you help, to suggest you to help. And this is very important because the way we win is the way we work together from the start until the winning stage. Okay. I don't see any questions, so thank you very much. Aviv, do you want to add something?
No, just to wrap up. Thank you, Goshen, for patiently answering all the questions. Thank you, everybody, for attending. I remind that this session was recorded. The presentation and the recording of the session will be posted on the Sales Enablement Wiki later on. So anyone who missed it or want to look at it again, you'll be able to do it. With that, I will say thank you and goodbye.